Yeah, this is Satsandi from Vignan's Nirula. Today I am here to tell you, to give you a presentation on colliding attacks, isolating the colliding attacks using Wormhole Path Watcher packet. So this presentation is supposed to be presented at for ICET 2016. So my paper ID is 186. So let us start. Basically, for wireless sensor networks. So my area is wireless sensor networks. So wireless sensor networks brought a major drastic change in the entire world because of certain significant characteristics of the wireless sensor networks. Firstly, it is self-configuring, so there is no need of configuring it, and especially we are in this session we are focusing on ad-hoc networks. Ad-hoc networks are it doesn't have infrastructure. There is no need of infrastructure, so there is no need of a base station. So every node acts like a router and as well as a node itself. So every router can behave like a node or maybe a router. So it depends on. So and also it is self-configuring, and also it takes a very little power and lots of applications regarding. So there is lots of applications which are drawn from this ad hoc networks, and also I can tell you. So many of the applications like the industry, medical, and all the other sciences are based on this ad hoc networks, and also the current IoT. So make use of this wireless sensor networks because of this broad area. So this is a very wonderful thing. This got its own problems. So here in this session we are discussing about the challenges or the security challenges in wireless sensor networks or ad hoc networks. So basically the ad hoc networks security threats divided into 3 layers. So you can have the security threats at the physical level and at the data link level, network level, and as well as the top level application level. So if you take the physical level and application level, so those kind of attacks are very hard to design and very easy to detect actually. So but whereas the network level attacks are very easy to design and very hard to detect. So that's the problem here. And so basically the attacks are classified, the network level attacks are classified into 2 categories again. So one is data traffic attack and control traffic attack. So data traffic attack basically we'll talk about. So generally the nodes will exchange the packets between them. So the intruder or the attacker will try to take the packets, and also they try to corrupt the packets, or they may try to drop the packets in that way. And control traffic attack is something like generally these nodes will exchange the control information between them. So while they are exchanging control information, so these attackers make use of the control packets, and so they just do the attack. So if you see here, so data traffic attack are basically like say black hole and grey hole kind of attacks. There are different kinds of, and control traffic attacks are basically categorized. Basically, it's a they will do man in the middle attack, and as well as so wormhole attack. So today we'll talk about the wormhole attack. So let us go through the wormhole attack. So wormhole attack is basically a kind of attack which the sensor nodes while communicating with each other, so one of those, so more than one of the sensor nodes will be the attackers. The attacker nodes will the compromised nodes or will form a tunnel like this. If you see here, so X and Y. 5. So X and Y. So the X and Y will form a kind of tunnel. So here, when these are communicating, these other nodes are communicating. So these attacker nodes, what they will do is, so they will take this traffic and try to move this traffic over them. So these have certain types of so what are the main problems here is, so the attackers can drop the packets, they can drop the packets, or else they will sense the traffic actually. So they can, all the traffic will go through them, so they may sense the traffic which is going through them. So this is a wormhole attack, so which is very hard to detect actually, because these nodes, the attacker nodes, suppose X and Y, they behave like a ordinary nodes. We can't identify these nodes. So in order to identify these nodes, so we formed a solution in order to identify these nodes. So which is the basic theme of our project actually. So this is based on so detection of wormhole attacks using W2W, so wormhole packet watcher packet. So here we make use of three things, so which is hop count, delay, and WP packet. So you know hop count, the number of hops the packet will move from source to destination, and delay, the time taken for the packet to reach the destination, and WP packet, it's a kind of packet which is a wormhole path watcher packet. It's a kind of special packet, so which is very lightweight, which doesn't carry any data, but it contains certain information like source ID, destination ID, sequence number, hop count field. So with this packet, so we devised an algorithm, so in order to detect this wormhole attack. So let us go through this algorithm. So let us go through the steps of this algorithm. So basically this algorithm is divided into 4 steps. So in the first step, so root discovery. So in the root discovery step, so we'll talk about how these attackers we'll take this wireless sensor network, so Ad-hoc networks, and we'll basically want to traverse the route. In step 2, we'll send a wormhole path watcher packet from the source to the destination. So in step 3, so we are just sorting the suspected paths actually. So in step 4, we finally compute the attacker nodes. So let us go through these steps in very detail. So let us take the first step. So here we take the delay and as well as hop count field here. So what we will do is, initially we'll take the delays of all the nodes from each node to the destination, source to destination node, and also the number of hops. So it goes to the step 2. Now the step 2, what we'll do is, we just take the number of hops as 4, hop count as 4, and whoever the packets which is having, in the step 1 we calculated the delay, right? So if the delay is greater than 100 and delay less than 10, means if there is more delay or less delay, so what we're going to do is, we're going to take a loop here. So here, so we're going to send wormhole path watcher packets like 4 at a time, 4 wormhole path watcher packets, so to the destination. So at least we must obtain at least of 3 or more acknowledgements. So if 3 or more acknowledgements are not received, it means that there is a chance of a attacker node between them. So if the 3 or more acknowledgements are received, there may not be there is a wormhole. So if there is a wormhole, we'll immediately go to the step 3. In step 3, what we're gonna do is, so we're gonna detect the suspected nodes. So we're gonna put all these suspected nodes into a ID of I, so an array ID of I. So we're gonna push all these nodes into this array, and we're gonna repeat step 1, step 2 and step 3 again and again until all the nodes until we cover all the nodes. So here in step 4 we finally compute, so we just means we covered all these step 3s for different types of source and destinations. So for all these different types of source and destinations we have different IDs, actually different ID arrays which are calculated. So finally we gonna compare these ID arrays together to see the common common fields, so common IDs. So the common IDs are nothing but the attackers. So that's the algorithm. So this is the actual algorithm. So here we also devised the we have also did the performance analysis. So in the performance analysis we used network simulator 2 for performance analysis for 10, 30 and 50 nodes, and actually we use AODB algorithms for that. So here what we did is we did a comparison between AODB with path watcher packet and AODB without path watcher packet. So here the following metrics for the following metrics we have devised. First is packet delivery fraction, means number of packets that are delivered to destination. Next is throughput. Throughput means the amount of data that is sent to the destination. End-to-end delay, so the amount of delay that takes for a packet to reach the destination. So let us see these graphs. If you see these graphs, so this is the end-to-end delay. So end-to-end delay for 10 nodes